What if one day, Earth simply stopped protecting us? No warning, no explosion, just silence, and suddenly everything changes. Radiation starts pouring in from space. Satellites fail, GPS dies, planes reroute, skin cancer rates rise, animals get lost, migrating birds fall from the sky. Entire power grids collapse in minutes. Billions of people back to the dark ages. All because of something you've probably never even thought about: Earth's magnetic field. Deep under our feet, molten iron spins and swirls. This iron ocean, Earth's liquid outer core, is in constant turbulent motion due to heat and rotation. Radioactive heating drives convection currents in the core, effectively turning Earth into a giant electrical generator. These moving currents in the electrically conducting iron create powerful magnetic fields. As NASA describes, the churning metals in the core act like a massive generator called the geodynamo, creating electric currents that produce the magnetic field. In simpler terms, the geodynamo is what powers our magnetic field. Imagine a bicycle dynamo spinning underground. The flow of liquid iron in Earth's core creates a loop of electrical current. This in turn builds the magnetic field that surrounds Earth. The field lines arch from the magnetic North Pole to the South Pole, enveloping the planet. Scientists often visualize it as a huge bubble of magnetic force surrounding Earth. In reality, the situation is complex. Contributions come not just from the core, but also from magnetized minerals in the crust, ocean currents, and even the ionosphere. But the lion's share comes from the core dynamo deep below. Over time, the magnetic field fluctuates. Shifts in core flow make the poles wander and can even slowly reverse them on geologic timescales. NASA notes that because of these changes, the magnetic north and south poles gradually shift and completely flip locations about every 300,000 years or so. By the way, the last full flip was roughly 780,000 years ago. Thankfully, these flips take centuries to millennia, not hours. Our magnetic field isn't just a scientific curiosity. It sustains life on Earth. Here's how it helps us every day. Blocks deadly radiation. The magnetosphere, Earth's magnetic bubble, repels and traps charged particles from the sun and cosmic rays. Most of this high-energy radiation is captured in the Van Allen belts, donut-shaped zones above the atmosphere. In effect, those belts safeguard the surface by keeping harmful particles at bay. Preserves the atmosphere. The solar wind is a constant stream of charged particles from the sun. Left unchecked, it can slowly strip away a planet's air, as it did with Mars. But Earth's field deflects the wind, preventing severe erosion of our air. In short, the magnetosphere is like a buffer that keeps the solar wind from peeling off the atmosphere. Protects technology and life. When the magnetic field is strong, it lessens the impact of solar storms on our technology. NASA scientists warn that if the field weakens, space weather, geomagnetic storms, can threaten spacecraft and astronauts, and disrupt navigation systems and wreak havoc on power grids. In past solar storms, like 1989's Quebec blackout, magnetic fluctuations have indeed knocked out power and crippled satellites. A robust magnetosphere means fewer surprise outages. Guides navigation. Many creatures, from sea turtles to salmon, and even certain birds, are born with a built-in compass. They sense Earth's magnetic field to navigate long migrations. Disrupting that field could confuse these animals, threatening ecosystems in subtle ways. In summary, Earth's magnetism is a cosmic umbrella. It deflects lethal radiation, protects our air, keeps the power on, and even guides wildlife. Lose it, and the world as we know it changes dramatically. What if our magnetic shield faded or flipped? Imagine the following unfolding like a Hollywood disaster trailer. Radiation on the rise. Without full magnetic protection, more solar and cosmic radiation would reach the upper atmosphere. Satellites, normally guarded by the field, would be pelted with charged particles. Their electronics could malfunction or fry. This means disrupted phone and internet service, damaged weather satellites, and broken communications. Even crewed spacecraft and high-flying jets would be exposed to more radiation than usual. Power grids at risk. We already have a hint of this when the magnetosphere is shaken by storms. Strong geomagnetic events induce currents in power lines, enough to topple transformers. In a weak field scenario, even moderate solar storms could trigger cascades of blackouts worldwide. Suddenly, the lights could go out in entire regions as the grid goes down. Navigation chaos. Compasses would become unreliable. They might even flip randomly as the poles wander. Ships, hikers, and animals depending on magnetism would lose their sense of direction. GPS signals might also suffer distortions when the ionosphere is bombarded by radiation. Imagine lost flights and misrouted ships because north itself is uncertain. Atmospheric changes. More charged particles hitting our atmosphere could break apart ozone and other molecules. Some theories suggest a weaker magnetosphere could lead to increased ultraviolet radiation at the surface. It's controversial how big this effect would be, but it's a real concern. Plants, animals, and even humans might see subtle increases in mutation rates or climate effects if UV levels rose. Ecological turmoil. With navigation messed up and more intense weather swings from solar effects, ecosystems could be stressed. Bird migrations might go awry. Marine life could suffer from higher UV exposure, and food chains could be disrupted. Imagine salmon unable to find their spawning rivers, or sudden die-offs of plankton under a withering sun of radiation. This sounds dire, and it is. Scientists studying magnetic reversals agree that the technological and biological impacts could be profound. In the worst case, Earth without its magnetic field would look and feel very different. But take a deep breath. Geologic history tells us that life on Earth has endured many magnetic flips with no obvious mass extinctions. In fact, detailed studies find no evidence of a correlation between mass extinctions and magnetic pole reversals. The fossil record doesn't show creatures dropping like flies every 250,000 years. Why? Because our thick atmosphere is still there to filter out the worst of the radiation. As one expert put it, even with a weaker field, the atmosphere would still provide sufficient shielding at Earth's surface that humans and animals would not be significantly affected. Moreover, magnetic changes are slow. A pole reversal or collapse doesn't happen overnight. It takes centuries or more. We would see warning signs over generations. Right now, teams of satellites, like ESA's Swarm mission, are literally circling Earth, mapping the magnetic field every day. Models of the field are updated constantly. For example, the World Magnetic Model is refreshed yearly. If a flip really started, scientists would have decades or centuries to adapt. Technology could be hardened, routes for satellites could change, and power grids could be designed to withstand storms. In short, we have time and information on our side. Yes, the idea of a weakening shield is scary, and the worst-case scenarios are frightening. But remember, Earth's magnetic dynamo has restarted after every lull. Life thrived through past flips, and researchers are watching it like hawks. So when your inner voice screams, "The sky is falling," quiet it with some facts. The magnetosphere is indeed a crucial protector, but it's not about to vanish tomorrow. For now, the northern lights will keep dancing safely at the poles, and your compass will point, more or less, north. In the end, the magnetic field is one more complex dance of physics on our dynamic planet. Dramatic in theory, but steady enough in practice to keep us safe.